Welcome. Today, we build a small but practical C# routine. Sum all positive entries in a rectangular matrix, but ignore or exclude any value that is located below a non-positive, which is less than or equal to 0 value in the same column. This pattern shows up when sensor readings become invalid, where a 0 or error code invalidates all readings below it, or in simple data cleaning tasks. We'll walk through the idea, then implement a robust, easy to read C# function with tests. Let's go. The rule is simple. Iterate column by column, and for each column, add the numbers from the top until you find a 0 or a negative number. Once you encounter such a number, or such a value, every entry under it in the same column is ignored. Note: zeros at the top cause that whole column to be ignored. Positive values above zeros count normally. This is easy to implement and runs in linear time in the number of elements. Here's a compact and safe implementation. I've added null and rectangular checks, so this function fails fast on bad inputs instead of giving subtle bugs. We iterate columns first and rows second. That way, we can break a column early when we see a non-positive value. Tests in main show the example matrices and the expected outputs. This approach runs in big O rows times calls time and uses only a few ints of extra space. Mechanically, we check input shape, get the number of columns, then loop columns. For a column, we move top to bottom. As soon as we hit a 0 or negative, we stop that column. The virtue of this method is clarity and correctness. It is local and easy to reason about, and it also maps directly to the problem statement. Here are the examples we've ran. For the first example, the first column has a 0 at the top, so nothing counts. Other columns add top values until a 0 appears. The table makes it easy to verify the result manually. These walkthroughs are great for testing edge cases like zeros at the top, zeros in the middle, or no zeros at all. This small pattern shows up in many places, where an upstream measurement becomes invalid. We often want to ignore downstream measurements in the same column, or time bucket. It is also a useful teaching example that combines array indexing, bounds checks, and early loop termination. To sum up, this is a simple, robust pattern. Per column scanning would break on non-positive values. It's easy to implement correctly and efficient enough for typical data sizes. If you want, you can produce a version that accepts a CSV or console input, add unit tests for the function, or produce a version returning a mask of eligible cells instead of just a sum. Thank you for watching and happy coding. Thank you for watching. If you enjoyed this video, please make sure to like, share, and subscribe for more C# tutorials. I'll see you in the next one.